Hi everyone, this is Dr. Ranjani, Assistant Professor of Physics, RMD Engineering College. Today we are going to see a topic in Unit 1, Laser and Fiber Optics, in the subject Physics for Electronics Engineering. The subject code is 22PH101. In Unit 1, Laser and Fiber Optics, we have the derivation part of Einstein's coefficients A and B. Here, when a material medium is exposed to electromagnetic radiation like light, three quantum processes take place. They are stimulated absorption, induced absorption, or simply absorption. Then spontaneous emission and stimulated emission. Einstein derived an expression that relates all the three quantum processes. For simplicity, let us consider in an atomic system there are only two energy levels, E1 and E2. Here E1 is the lower energy level, E2 is the higher energy level, and usually the population of atoms at E1 will be greater than the population of atoms at N2, that is at E2. Number of atoms at the lower energy level will be greater than the number of atoms at the higher energy level under thermal equilibrium conditions. Now we are going to explain about the three quantum processes one by one. What is absorption or stimulated absorption? When an atom at the E1 energy state, lower energy state, is raised to the higher energy state with the help of an external triggering photon of energy h nu, then this process is called as stimulated absorption. This is expressed by the expression R12, the rate of absorption. Here 1 to 2 denotes the absorption of atom from the first energy level to the second energy level. The rate denotes per unit time or in 1 second. So the rate of absorption is equal to N1 B12 rho nu. N1 is the number of atoms at the E1 energy state. B12 is the probability of absorption transition per unit time. In 1 second, how many number of atoms are absorbed? That probability is given by this B12. Rho nu denotes the energy density of incident radiation. Spontaneous emission can be defined as the atoms at the higher energy state is emitted or returning to the lower energy state E1 spontaneously without the help of any external triggering photon. It is called as spontaneous emission. During this process, a photon of energy h nu will be emitted. This can be expressed as R21, that is the rate of emission. Here Sp denotes the spontaneous emission. It is equal to A21, the probability of spontaneous emission transition per unit time, and N2, the number of atoms at the E2 energy level. Stimulated emission can be defined as an atom at the higher energy state returns to the ground state not spontaneously with the help of an external triggering photon of energy h nu. During this stimulated emission process, two coherent photons of energy h nu will be emitted. This is expressed as R21st, which is equal to N2 B21 rho nu. N2 is the number of atoms at the E2 energy state. B21 is the probability of stimulated emission transition per unit time, and rho nu is the energy density. Now, under thermal equilibrium condition, the rate of absorption is equal to the rate of emission processes. This emission process is spontaneous and stimulated emission process. We have substituted the expression of the rate of absorption and rate of emission, and then it is rearranged. That is, the second term in the RHS is taken to the LHS, and we arrived up to this equation. Then rho nu is taken as the common term. The remaining is kept within the bracket, and it is taken to the denominator of the right hand side. Now we arrived up to this equation. Then on further simplification, that is dividing the numerator and the denominator by this term N2 B21, we get this N2 get cancelled off. So we get A21 by B21, and then 1 divided by here N1 by N2, B12 by B21, and then N2, B21, these two get cancelled off, we get 1. Then A, B are the constants. N1, N2 denotes the population of atoms at the E1 and E2 energy states. We need to find the expression of N1 by N2. That is the ratio of N1 by N2. Boltzmann distribution law is taken here. The general expression to find the number of atoms in the particular energy level is Nn is equal to N0 e power minus En by kBt, where kB is the Boltzmann constant and N0 is the number of atoms in the lower energy state or the ground state, and T is the temperature at which this process is considered. Now, since we need N1 and N2, this N is replaced by 1. That is, when N is equal to 1, the above equation becomes N1 N0 e power minus E1 by kBt. And then when N is equal to 2, we get N2 is equal to N0 e power minus E2 by kBt. That is, we are going to substitute N is equal to 1 and N is equal to 2 in this equation. Then we have N1 and N2. Now N1 divided by N2. We are substituting the equations. Then N0, N0 get cancelled off. Then e power minus E2 by kBt in the denominator is taken to the numerator. Thereby we get e power minus E1 plus E2 divided by kBt. Then E2 minus E1 by kBt. The difference in the energy level E2 and E1 is given as h nu. We know the energy is equal to h nu. The difference in the energy level is taken as h nu here. Now substituting the value of N1 by N2 as e power h nu by kt in the equation. This rho nu is equal to A21 by B21, 1 divided by B12 by B21. Here, instead of N1 divided by N2, we are using e power h nu by kBt and minus 1. This equation is in good agreement with the Planck's law of black body radiation, which is given as rho nu is equal to the energy density of emitted radiation of a black body is 8 pi h nu cube by c cube into 1 divided by e power h nu by kBt minus 1. Comparing the equations, we get A21 by B21 is equal to 8 by h nu cube by c cube. This is equated with this, and then we have e power h nu by kBt minus 1 here. Here also we have e power h nu by kBt minus 1, and then here B12 divided by B21, this can be equated with 1. So we can conclude that A21 by B21 is directly proportional to the third power of the frequency, that is 8 pi h and c cube are all constants, they will not change, but the only change in value is the frequency. Therefore, or even I can take it as the energy. Since h is constant, the changing value is frequency, therefore nu cube is considered. The ratio of spontaneous to stimulated emission process depends on the energy difference between the two energy levels. Then B12, stimulated absorption divided by stimulated emission is equal to 1, which is the stimulated absorption is equal to stimulated emission probability transition is concluded. So the results have been given as the stimulated emission rate is equal to the stimulated absorption rate, and then A21 by B21 is directly proportional to nu cube, which shows that the spontaneous emission transition increases very rapidly with increase in the energy difference between the two states E2 and E1. If A21 by B21 is very much lesser than 1, then B21, which is the stimulated emission process, will be predominant, very much greater than the spontaneous emission process. So for laser transition or laser radiation, stimulated emission is the key factor. Therefore, for stimulated emission process to occur, the stimulated emission process should be made predominant over the spontaneous emission process. Thank you.